Welcome to a video on elementary physics, resistance combinations. Resistance combination in parallel and series. This is a common question in electricity and physics for classes 8 to 10. And here we give the easy steps understanding series and parallel resistance combination concept. So here we have a circuit where you can see resistors are arranged both in series and parallel, and we have to calculate the total effective resistance. So the simple method, easy step-by-step method, let us see how to calculate the total effective resistance in this circuit. So look at the blinking rectangle. The blinking rectangle on the right and the blinking rectangle on the left. So on the left, 2 ohms and 2 ohms are joined in parallel. Look at the left hand side figure. Blinking rectangle. Inside the blinking rectangle, 2 ohms and 2 ohms are joined in parallel, and on the right side they have been replaced with an equivalent resistance of X ohms. That means 2 ohms and 2 ohms in parallel should be equal to X ohms. Now let us calculate the value of X. 2 ohms and 2 ohms in parallel is replaced by a single equivalent resistance of X ohms. So let us see the value of X. So we replaced 2 ohms and 2 ohms in parallel with X ohms. So using the formula for parallel combination, we get 1 by X equal to 1 by 2 plus 1 by 2. 2 ohms plus 2 ohms in parallel should be equal to X ohms. So the formula for parallel resistor combination will be 1 by X equal to 1 by 2 plus 1 by 2. Half plus half is 1. So 1 by X equal to 1, that is X equal to 1. So the required equivalent resistor would be 1 ohm. 2 ohms and 2 ohms in parallel can be replaced with a single resistor of 1 ohm. So we have already replaced the parallel combination with a single resistor of 1 ohm. Now all these are in series. Look at the right side. Look at the right side. This parallel combination we have already replaced with a single resistor 1 ohm. Now all are in series. Series 2 ohms, 1 ohm, 2 ohms. 2, 1, 2. So the net resistance in series would be given by 2 plus 1 plus 2 in series. So we simply add 2 plus 1 plus 2, that is 5 ohms. So the required resistance is 5 ohms. The net equivalent resistance of this combination of resistors in series and parallel, 5 ohms is the final answer. So this is how we calculate step by step when we are given resistors combined in series and in parallel in a circuit. And that was a video for junior and middle schools and high schools, how to calculate equivalent resistors when resistors are combined in series and parallel. Step by step easy method. Follow us for elementary science and math concepts. Subscribe to the channel, share and like the videos. We shall come back again with more interesting and useful videos for school students. Till then, thank you and goodbye.